So welcome and thank you for having me here today. I really hope that you will get something useful from my presentation. So the presentation title is Secure Static Site on AWS, S3, CloudFront, Terraform and Lambda Edge. So don't worry if you do not understand any of those services or you just recognize some of them. I will describe each of them and you will be able to comprehend the whole title. So as you can see, our agenda is a bit packed, so I will probably run out of time. So if you have any questions about the presentation, please wait with them until the end of presentation. And if we will have enough time, I will answer them. So I will start with who am I, why I think I'm allowed to talk about all that stuff. I will introduce the concept of dynamic runtime and static hosting, and I will tell some advantages and disadvantages of each solution. I will present our baseline security requirement list when we're talking about serving front-end application. And I will describe tools and solutions that we are using to serve front-end applications. Thank you. So who am I? My name is Karol Kozakowski. I work as a DevOps engineer, and I'm really interested in anything that relates to programming. So if you want to talk either about the presentation or anything that relates to basically programming in general, feel free to reach to me after the talk or ping me on any social media. I work for a company called Artificial Labs, where I'm responsible for everything that relates to AWS, cloud, and security. And that means that I'm responsible for creating and managing cloud infrastructure and keeping that as secure as possible. So at Artificial Labs, what we do, we create products for insurance companies from all around the world. And the main interface for those products are web applications. So in our case, that would be a SPA, single-page application written in React and deployed on AWS Cloud. So we had to come up with an idea how we want to manage all of that, and we had to invent our own way of managing and scaling the solution that we are using for serving front-end applications. So basically this talk will be a description of the process that we did, decision that we've made, and how we are solving this problem today. Okay, so I'm missing a slide. In here is a GIF when people are raising hands. So raise your hand if you are using a dynamic runtime to serve your front-end application. So if you're using Node.js runtime for that. Okay, so we don't have a lot of people in the audience. Okay, so now raise your hand if you're doing that in a static way. So for example, using CDN. Okay, much more people. So up until I think like 2 years ago, we as Artificial were in the first group. We were using Node.js to serve all of our front-end applications with help of Elastic Beanstalk. And now I'll present the journey that we took with almost all of our applications and with what we end up with. So basically, most of the applications start like this. You have user on the bottom of the diagram, and you have your front-end server, and user is interacting directly with the front-end server without any additional layers in between, and it works. You can iterate on your product. It works with a couple of users, maybe a couple hundred of users. You don't need to worry about anything until you start to think about resilience, redundancy, and availability of your solution. So you invent something that will most probably involve DNS-based load balancing. So you add another server. Your user is now interacting with the front-end server with one URL, but under the hood, those are two servers, separate servers. So you're able to handle much more load because you have two servers that you can use, but you still need to think about all the issues that you had before. So you've increased resilience a bit and you've increased redundancy a bit, but you need to think about having enough capacity in each server to be able to handle a situation that one of your servers goes down and you need to start serving all of our traffic from the one server, for example. And it scales pretty well, again, until some point that you start to think again about redundancy and having a better availability and much higher availability and being able to scale to a point that much more users are able to interact with your website. And also you want to handle the spikes of traffic that are coming to your servers. So you start using a load balancer in between. Load balancer is just a solution that will balance incoming traffic to multiple front-end servers in this situation. So it's fairly similar to the load balancer that are used in the backend. basically. So you have your user. Your user is not interacting directly with the front-end server. It's interacting with a load balancer, and the load balancer has to have quite a lot of knowledge about where to route traffic and where this particular request should be sent to which server. So it works, once again, but you've just introduced yet another fairly complicated component into the whole solution. So you need to start worrying about keeping front-end servers secure and updated and upgraded. You need to think about keeping updated and upgraded your load balancer, and you've just introduced quite a lot of moving parts just for serving static files, basically. So you want to scale once again, and you want to have a redundancy layer on your load balancer layer, basically, for example. So you just need to dig this horizontal scaling topic, and it's huge, and you really don't want to do that just for serving static files, but you'll probably end up with something that is similar to this diagram. So basically, you have multiple load balancers that are able to proxy traffic to multiple front-end servers. And now you have quite a lot of moving parts that you need to keep track of, and you need to think about them. You need to spend quite a lot of resources on keeping everything updated and upgraded. On top of that, you still need to think about your application. You still need to keep the application secure. You need to iterate on business features and basically provide value, but you also need to keep everything running in this fairly complicated software architecture. So at this point, we as Artificial decided that we don't really want to spend resources and money and time on that, and we want to have a simpler and much more scalable solution. So we've decided that we want to start using static hosting to serve our front-end applications. So this is basically an architecture that we have right now. So your user is on the bottom of the diagram. User is interacting with a SPA that is deployed on CloudFront. S3 is used as an underlying storage for our CDN. And we have Lambda Edge function that is responsible for injecting various HTTP headers that are enhancing security of the platform. So going from multiple moving parts and servers that you need to keep secure and running, we've moved to a platform that you just need to think about services, and there's no concept of server, and everything runs on the cloud, and you don't need to worry about these basic details of keeping everything updated, upgraded, and secured. So what are the advantages of static hosting compared to the very complex solution that I described before? So it's almost free. So you don't need to spend money on servers, and you don't need to basically spend a lot of resources on people that would be handling only keeping track of everything that relates to your servers. And the cost of the static solutions scales with the usage of the solution. You don't need to think about keeping free capacity in case that there is a spike of traffic that comes to your application. It has sane defaults out of the box, and by sane defaults, I mean most of the cloud providers and providers of content delivery networks and things like that. The defaults of those platforms are fairly good, and you don't need to spend quite a lot of time tweaking bits and pieces of the platform that you've chosen and keeping everything updated. And it's much more scalable, so it's much easier to go from a couple of users interacting with your website to a couple thousands of users interacting with your website, because you don't need to think about this horizontal and vertical scalability. You don't need to keep track of having this free capacity available for you at any time. You don't need to spend time on that. You just create a distribution, and that's all. It will automatically scale no matter what type of traffic income is there and what type of users and how many of them are interacting with your website. And a big win, at least for me, is that you don't need to manage servers. There's no concept of firewalls and keeping OS updated and upgraded, and it's just gone, and you just think about services instead of thinking about servers and keeping them running all the time. So when we've decided that static hosting is a way that we want to go, we've created a basic security requirements list. So like this requirements list was there before we decided to move to static hosting, but this list is something that every website, no matter what type of website we put online, so that can be a blog, our company's website, or a full-blown front-end application, every website needs to meet those requirements. So those are the most important things for us when it comes to serving front-end application. So, and for me, the most important thing is you should be always using HTTPS to serve your front-end application. By HTTPS, I mean that connection between your client and your server should be encrypted, and that there is no way of intercepting that traffic. And this also increases the confidentiality that your user is in fact interacting with a website that he wants to interact with. So the times of like super expensive SSL certificates and super long procedures of obtaining them is long gone. With services like Let's Encrypt or AWS ACM, it's super easy to create a SSL certificate, use them, you can automate that. So basically, I don't see any reasons of keeping unencrypted websites available for your users, especially if you're handling sensitive information such as logins and passwords. Another thing that is important for us is a content security policy. Content security policy is an HTTP response header that is used by browsers to enhance security of your website. And I will describe that in details in a minute. And the third thing, you should be always serving static files from Content Delivery Network. So Content Delivery Network, or CDN, is a set of geographically distributed proxy servers that are super performant when it comes to for serving static files. So let's imagine a situation that you have an application. Your application servers are located in United States, and I want to fetch those resources from here in Poland. So without the CDN, I need to do this really high latency HTTP request back to the United States. I need to cross the ocean and two continents just to fetch an index HTML to be able to basically show a static file. But if you're using Content Delivery Network, instead of requesting that directly from the servers of your application, I will be just redirected to the closest possible location. That is the closest possible location to me. So I will just have quick hop to fetch those resources instead of going across the ocean. So it's not as much about, using Content Delivery Networks is not as much about security, but it's more about user performance and user experience when user is interacting with your website. So here are the tools that we are using to create that solution. So we are using Terraform to manage all of our cloud resources, and basically Terraform is an infrastructure as a code tool that allows us to create reusable components and manage all our cloud resources. But of course, you're not forced to use Terraform. You can use serverless, or you can use CloudFormation, which is a native AWS solution for infrastructure as a code. And you can also use something that's called AWS CDK. That's Cloud Development Kit, not Software Development Kit. And AWS CDK allows you to write JavaScript files that upon execution will create resources in the cloud. And of course, you can use, if you're using any other cloud provider than AWS, you can use a native solution that is available for that cloud provider. We're using S3. S3 is a simple storage solution, so that's one of the first publicly available services that Amazon made. And that's an object storage that can be used as an origin for CloudFront. CloudFront is our CDN. It integrates with S3 in a way that you can put build your application and put those artifacts in S3 and use CloudFront to cache them, and basically you can fetch these resources from CloudFront. From what I know, you can also achieve almost the same setup with Cloudflare. So Cloudflare has something that's called edge computing, and edge computing allows you to run basically Lambda functions as a service on edge of the Content Delivery Network. On AWS, we're using something that's called Lambda Edge, and Lambda Edge is just a solution, basically a function as a service from AWS that I will describe in a moment. So I will start with Terraform. As I said, infrastructure as a code tool that allows you to describe how your infrastructure should look like, and you don't need to worry about underlying API calls and thinking about how you want to create all those resources. Just declare, this is how my infrastructure should be looking, and Terraform will take care of rest. So in this case, we can, for example, say that we want to have an S3 bucket with warsawjs.com name. files in those buckets should be publicly available, and you can enable hosting for that bucket. So we are using Terraform basically as a way of creating reusable modules that will create all parts of, like, all infrastructure that is needed to serve a website, and we will, thanks to that, we can reuse that across all of the projects that we have. So CloudFront, as I said, is our CDN. It has truly global scale, so 205 edge locations all around the world, and edge location is basically a set of servers that are located in the data center somewhere in the world, and they are used to speed up the performance of your application. And instead of requesting that resource directly from the server, you will be using the closest edge location that is possible. CloudFront integrates with existing AWS services. So, for example, you can use AWS ACM to obtain free SSL certificates. So we're able to use custom domains for your CloudFront distribution. It integrates with WAF, so that's Web Application Firewall. So you can shield your front-end application, and, for example, WAF is able to detect SQL injections that are sent to your application, and as well it can detect bots and all that malicious traffic that your application that people all around the world are hitting your application with. Also, it integrates with CloudWatch, so that's monitoring and alerting solution. You can have proper monitoring and proper alerting with everything that happens with your CloudFront distribution. And of course, it integrates with Lambda Edge. So AWS Lambda is a function as a service solution, so you can run code based on events, and you don't need to manage any servers or Docker containers, anything for that. So you just write business logic. It will be run based on events, and Lambda integrates with CloudFront with something that's called Lambda Edge. So you can run Lambda functions based on for events that are coming from CloudFront. So here are the events. So on bottom of the diagram, you can see a user. User interacts with CloudFront. If the resource that user wants to fetch is already in CloudFront, so it's cached, there will be a viewer request event sent. And for example, you can use this type of event to create basic authentication without writing any backend code. So you can create a Lambda function that will check if the header is set in the incoming request. And if that resource was cached in the CloudFront, there will be a viewer response that we will be using in a minute. So the origin request and origin responses are happening if the resource that the user wants to fetch is not cached on the CloudFront. In that case, CloudFront will fetch this file directly from the underlying storage, so from S3 in this case. So now content security policy. As I said, content security policy is an HTTP response header. So you set it on the response that it sent from your server to the client. And basically this is a set of rules that your browser will keep track of and enforce upon your application. So in this example, this is the simplest possible CSP header. So you set a directive, and that's the value of that directive. So default src directive means that if any other directive is not set, use this value. So in this case, that means that any resource is allowed to be loaded or requested or fetched as long as it's coming from exactly the same domain that your website is hosted under. So you can request stylesheet and JavaScript files from exactly the same domain that your website is using. So in a situation that, for example, you want to interact with external API that is hosted under a different domain, you can specify that you can load anything from the same domain that your application is hosted under, but also you can use any subdomain of the trusted.com domain. So in a situation that you want to allow your application to, for example, embed iframe or interact with some API, you need to write that down explicitly in the content security header. And here we have a much more complicated solution. So for example, you can set script src. Script src directive is responsible for anything that is related to loading script files, for example. So you can allow script files to have inline code and execute that inline code if you don't have the unsafe inline value set for script SRC, and the inline code that application tries to execute is rejected. You can use connect SRC to allow sending HTTP requests to the whitelisted domain. And you can also use, for example, style SRC. So this report URI directive is really interesting. So the value of that directive should be an URL that your browser will use to automatically post JSON messages with the CSP violation that happened on your website. So you can have like proper alerting that something went wrong on your application. Here's a link that has much more details about CSP and all there is a list of all the directives that you can set, and I think it's like 8 of them or 9. So Lambda Edge is used to, like, we start Lambda Edge based on the viewer response event coming from CloudFront. So that means that we are able to fetch a response that is sent back to the client. So we'll be using that. So we'll use a handler. You can write Lambda Edge functions in JavaScript. You can use also async and await syntax if you want. And you can write them in Python. So this is how the handler looks like. You get an event, use that event to fetch the response that is being sent, and you fetch headers of that response. So what can you do with those headers? So, for example, you can implement much better caching for the files that we are using. So, of course, CloudFront has its own cache settings, but maybe you want to have a much better and more fine-grained control over what are the values of cache control headers that you are sending. So this is really useful in a situation that if you're using CDN, invalidation of the files that are cached on CDN can take quite a lot of time. So that header might help you because browser won't be caching anything on the browser side. You can implement something that's called strict transport security header. And as you remember, first point on requirements list is to ensure that your website is always served with HTTPS. So this header will tell browsers that it should be interacting with any resource that has this header set with HTTPS. So your browser won't allow to downgrade the connection from HTTPS to HTTP. And last but not least, content security policy. So in here, you can inject all the CSP policies that you want to inject. So in this example, I know that indentation is a bit off, but in this example, let's imagine that you're a bank. So you set default SRC to none. So if there is no whitelisted directive that is set, any other will be rejected. So this is super useful if, for example, you know that you won't be using iframes on your application, and you just set default SSL to none. We do not have an iframe directive here. So even if someone hijacks your application and wants to embed an iframe that will do some malicious stuff like fetch credentials or anything like that, that browser will disallow of embedment of that iframe. And what is quite important with that is that content security policy headers are enforced on browser level, not your application level. So you can have a whitelist of domains that you know that are good and that your application is able to use, and basically disallow any other. So any questions?
I have one.
Okay.
Yeah, so I will just hold the microphone so you don't have to touch.
No touching. Okay. So all this setup requires to actually use the serverless infrastructure. Is it correct?
Yes. So we get rid of servers, and instead we are using services that are available for us on AWS.
Okay. So without Lambda in this picture, have an API also as a part of this picture a bit complicates the whole thing.
Not really, because in this case you can host your API in a way that you want. So basically that will be just an URL that is somewhere in your application code, like front-end application code, and you just need to remember to include that API in the content security policy header, and your application will be if that's a serverless function, or if that's a serverless solution, like in this case, that's just an API.
Sure, but I'm referring more to the first part of your talk about.
Okay, yeah, with the dynamic runtime, right? Yeah, so I've decided to just leave the backend. Backend is somewhere there, and for this talk, I'm not worrying about ensuring that the backend is secured.
Yeah, that
basically
that was convenient
Yeah.
on your side. So I just wanted to.
Yeah, we will
clarify.
need much more time to to implement security on the backend side.
Okay, fair enough. Thank you.
Thank you.
Okay, I also promised to answer to some questions on YouTube. So, okay, no questions. There is one more.
He works with me, so that's cheating.
False crown.
Yeah.
And that's the thing I don't know yet. Cool, very cool presentation. I
Thank
really did enjoy that. So, question about the reporting. Since you said there is some directive that you can send reports from your browser, how does it work?
Yes, so basically you can use report URI directive to set an HTTP URL, like a URL that your browser will automatically post a JSON message that will contain a directive that was violated with the value that violated that directive. So you can have a Slack bot or anything, or some reporting service that will say that on this website someone wanted to embed iframe, but we disallow iframe on that website, for example.
Specified schema that's being used.
Yes. So basically that will be always the same
Yeah,
JSON
so there
schema.
is a specified schema that's
Yes.
going to be used.
Yes. So the message always looks the same, and it's implemented on the browser level, so there's no way of adding any more useful headers or anything like that. So that's a black box solution that just sends post a JSON message.
Is there any
Yeah, thanks.
URL structure for that?
So
Sia asks if there is any required URL structure for this.
I don't think so. You can just have a API URL there, and you don't even need to return a 200. So you can just get that message and forget about sending any responses, and browser will handle that.
Okay, so last question? No questions. Okay, thank you very much, Karol.
Thank you.